thanks for joining, everybody. We had some tech difficulties, back on track. So thanks for coming to our session, Scaling Agentic AI Cost Effectively on Azure VMs. I'll do a quick intro. Nori, I'm in the software and ecosystem team at Arm, work closely with different Microsoft and Azure teams. So our agenda is we'll talk quickly about the partnership, our software ecosystem. You heard this morning in the keynote about Cobalt 200 VMs being in preview. Gova from Microsoft will step through that, and then Pranay is going to walk through a demo here. So just a quick intro from an Arm perspective for those that are not familiar. Company's been around 30 years. We've shipped close to 350 billion chips over that time span from a company perspective. And our platform really is the computing platform for all devices and from cloud to edge, right? In this context today, we're here really talking about data center and cloud and our partnership with Microsoft and Azure. And we have a strong developer community, as you can see. Our partnership and collaboration with Microsoft really hinges on two pillars. One is the silicon innovation pillar, and we work with the Microsoft hardware and systems teams on deploying and designing and developing the Cobalt chip. There's two generations. The prior generation started off with better price performance, about 50% than the prior gen, and Cobalt 200 now is about 50% better than Cobalt 100. And Gova will share some stats on in terms of the different workloads and benchmarks that we have so far. And then there's software enablement, right? So when it comes to software enablement, we have about 22 million developers in Arm. We've been building this ecosystem for about 15 years, and 95% of CNCF projects support Arm at this point. So across the different flavors and categories, you can see we work with a variety and most of the different open source packages as well as ISV software packages that are enabled and supported on Arm across Linux operating system, cloud native, so the CNCF Foundation, AI, ML, and variety of different SaaS and enterprise packages that run on Arm. So hopefully that gives you a flavor for the wide software support that's available. With that, I will turn it over to Gova to get into some details on Cobalt 200. Take it away.
Hey everyone, I'm Gova. I'm from the Arm product team at Microsoft. I'm very excited to talk to you today about the Cobalt 200 VMs. But before that, let's see what our success story looks like for Cobalt 100. We launched Cobalt 100 2 years ago in 2024, and since then, the response has been tremendous. We have several customers on enterprise side and the cloud native side that are interested in onboarding or have already onboarded onto our VMs and are experiencing very, very nice price performance benefits that Arm has to offer. And not just the third-party customers, we also have the first-party customers, the ones that you can look here. Like, for example, Microsoft Teams is running on Azure Cobalt 100, and we have Defender, which says Cobalt is their default processor to drive all their workloads. So such testaments come from the fact that our price performance is immense and unmatched compared to other offerings. Now, that was about Cobalt 100. That's yesterday's story. Now, today, Satya announced Cobalt 200 VMs, and Cobalt 200 and 100, of course, are processors that are in-house built, which means they are custom built, purpose-built for server space by Microsoft, which is optimized for Microsoft's first-party workloads and a variety of third-party workloads. And Cobalt 200 VMs come innately supported with Azure Boost. And as Samir mentioned, the VMs, the per core VM performance is at least 50% better than the previous generation. Cobalt 200 processor is built on a 3 nanometer technology on latest ARM architecture. Now let's talk about the VMs. We know the processor is immense and has tremendous per core benefits, right? So we want to translate all those benefits to our customers in terms of virtual machines. So we not only offer the D and the DP and the E series as Cobalt 100, but we extended that to the memory optimized version, wherein every core gets about 16 GB of memory, and the local storage, dense local storage optimized L series VMs for agentic AI and cloud native workloads. So overall, with all of these different VM offerings, we will be able to fit any workload that an enterprise customer or a cloud native customer can imagine. This is something that's more relevant for developers, right? So what you see here are the benchmarks that we've tested on our VMs. So on the left side, you have the industry benchmarks, the spec and rate, where you can see the comparisons across the board are compared to the previous generation workloads on a per vCPU performance basis. So the industry benchmarks and the Microsoft benchmarks, along with the Microsoft products, all speak the same story, that we are much better. We're delivering very high performance compared to our previous generation. Microsoft products themselves are a testament to that, and we run our own first-party workloads in addition to referring to our 3P customers. Lastly, before I hand over to Pranay, I want to talk about what is in store for the future, right? The future is about agentic AI. So on the agentic AI front, we see that Cobalt 200 is well suited as it is suited in the cloud native space, be it sandbox creation, be it creating a request and doing the entire loop, be it fitting as many sandbox agents into a VM. Cobalt 200 excels in all of these fronts and will provide unmatched price performance benefits. And with that, we have the regions. We currently have previewed in 8 regions, but we are going to expand those regions at GA. And if you have further questions, I'll hang around, but I'll pass it over to Pranay for an exciting demo. Thank you.
Thanks, Nori. You guys hear me? Yeah, perfect.
I'm going to sit down.
So, just a quick show of hands. How many of you are familiar with ARM or ARM64 in architecture? Great. So, I'll start there. So, what we are doing here, what we are showing is a transition. ARM as a company and an architecture, like Sunny and Goa laid out, how we transition or we launched the series for Cobalt 100 VMs. So, if you look at cloud native applications or more traditional applications, they had some very fixed workflows on you get to from point A to point B, execute a few tasks, and you are done. What now we are seeing as an industry is essentially the applications moving towards an AI first, AI native, or an agentic workflow inbuilt applications, where you can essentially take your applications and move them over to add that agentic capabilities. Now what's happening here is essentially with Cobalt VMs, they support both those families. Essentially with 100 and with 200 series VMs that Goa and Sunny talked about, we have these different workloads supported on these different families. So when you think about distributed microservices architecture, meaning your application is spanned across hundreds of nodes, and how you scale that application, all of that gets converted or covered when you run this application on Cobalt VMs. For a demo, that was a primer. What we are doing here today is showing a cloud native application that's running on the, if you look at, it's a busy slide, if you look at the first column, it runs a polyglot microservices-based application. It's a shopping cart, essentially, application, where you have all of your microservices running on Cobalt 100 VMs. In the second, or the orchestration tier, we are running it on the newer Cobalt 200 VMs, which are much more capable to execute on CPU inferences without need for any other external tools and whatnot. And the third is where we are essentially provisioning multiple pods to serve those inferencing requests generated by the application. One thing to note here is all of this is happening on a CPU and inside that cluster. So your data is not going outside, you're not talking to a third-party LLM, and everything is local and private. We have 3 different tiers. The first one is what we call 100 teams, which are your cloud native focused teams. And the second tiers are running on the newest Cobalt 200 VMs that we heard about at keynote. The application is a shopping container application. All of this and inferencing is running inside the ATS cluster. What you see here is what I'm going to do. Again, I'm playing it through a video, and I'm not going to touch it. So if you see here, all the nodes are running on Cobalt 100 CPUs. V6 is Cobalt 100 processors, while V7 is Cobalt 200 processors. And this has a cluster which mix for both 100 and 200 VMs. What we are showing here is that shopping application that's running entirely on this cluster. And you see it's running across all these different VMs. Right? So what I'm doing here to add the intent of this demo is not showing that our cloud application can run. The intent is that your existing application, you can add AI native capabilities, including inferencing and agentic AI within the cluster itself. So what you see here is that web application that's deployed on Arm, AR64 is the behavior. And now, when you go down, and what I've done here is added an orchestrator as a family of agents that's managing the life cycle of all the agents. We'll see in a second. The agent here is running everything in the CPU and including the inputs and the agent interaction. So all of these agents will be able to execute within the cluster, all local, without any need of an external entity. Now, if we go to the this is the agent orchestrator you see. The pod is running with the manager active. We have different pods that are essentially supporting this orchestrator service. If we go to the application, and it's all running on Cobalt 200. And this is the requests that are being generated, which we see in the application. Whenever you are using the chat interface, what's happening, I'll just walk through it. This is an existing application. Some of you are familiar of Indonesia. Now, as you can see, so that is the website. There are two skills, and being a lazy guy myself, I don't want to browse through all of this, and I'm trying to get in shape, right? So what I'm doing is I'm using this chat interface, and as you can see my card is working. I'm going to use this chat interface to see. I'll give it a prompt where I want to camp in gear, but I will give some limits and some categories that will have the exact items I want from the entire website. I don't want a random stuff. So what I do here is bring vehicle with items only under $2,000. Then I'll walk through the prompt right now. But if you see here, book very easy expert under $2,000, include exactly one pen, one backpack, one lighting item, and make sure that the budget is $2,000. What's happening here is it's still giving me a ton of cash. It gives me $1,200 worth of behavior. From here, I still have around $700 left. Now that you see there is an orchestrator service that's running, it's routing that traffic to a shopping agent, which is scanning the inventory, adding, finding those relevant projects, budgeting agent, which is cutting it into the budget, and inventory agent, and making the agents. But essentially, it's using an art agent and it shows me the list of items that are fit into the budget. Now, I think I'm missing shoes. I need some shoes, so I'm going to add it. You can see I was doing it late at night. I can't spend shoes there. And now, if I see, so I actually choose. So look at it, what happened. It did not give me a list of shoes because it was an inventory agent. It just gave me one that was available, that suited my needs, and now I do just add all of these items to the cart, and it should show up in my cart. So what happened here is it maintained that context. So the context was carried over because we are using a KB cache. The context was not, it did not go and do back and forth. So we saved on compute and cost. If you see all adding the tag, and this is a part of it, but what we really need to focus is all of this inferencing and those agentic capabilities were done all on CPU and in a local inferencing LLM. I'm using a 5-core mini model and an Onyx runtime to interface with it, and essentially the entire demo works on CPU inside the AKS cluster. That's it. Yeah. Maybe go to the next slide. To that. Yeah, these are some labs. We have a lab, Jamshid and I, we are doing a lab at 6:30, 9 o'clock, and 3 o'clock tomorrow. Sign up for these labs if you want to talk to us and you want to know more about the demos. Just come up and you can all do it by yourself. So we'll talk through all of that, the inferencing part during the labs. And lastly, we have this program called Arm Cloud Migration, where we help our customers and partners in their migration journey to ARM64. So in case you are just starting your journey, or if you are already well ahead and you want to do some performance analysis on CPU, we are there to help. Just reach out to us with this QR code, or just go to our website, arm.com/migrate, and we'll be happy to help. What you'll get is a migration resource hub and CP server to help with your migrations, and you'll also get engineering expertise for experts within Arm. And with that, we're done.
Yeah, we're done.
And thank you so much for coming. Yeah. Thank you.